Okay, we're good. Hooray, it's working. Okay. So, of course we're going to feel a little bit silly in here, just the two of us sitting around talking to each other for this week, but next week 2 students or 3 students or 4 students, I don't remember how many students, some number of students will be joining us from different sides, and we'll be recording this to send to other students as well. So we are certainly not alone. But let's go ahead and get started. If we look at our schedule again, I did post this stuff up on YouTube. Yesterday's little introductory lecture I posted on YouTube. And yesterday we had a video assignment and a video report. So if you do have your video report done, which hopefully you do, you can turn it in to me by handing it in if you're here, or you can turn it in by emailing it to me at my email address, daileyj, @mpcc.edu, or you can fax it to me, I guess, if you really want to. I have no idea what the fax number here is. Maybe it's on the sheet. Nope. Nope. So I don't know what the fax number is.
308-535-3794.
Oh yeah, it's on the, that's the extra one. Yeah, 308-535-3794. Try that and see if it works. You can fax to that if you like, or you can, if you're at one of the, I don't think anybody's at an extended campus where they could send it by campus mail. You can send it by regular U.S. mail if you want to. It's whatever, I don't care how you send it here. Just make sure you get those turned in. Should be a 1-page typed report that it should include the titles and websites of the videos that you watched. It should have been 60 minutes of engineering video. And you should tell me about it and tell me what interested you about it, and so on. Today is Wednesday, and we're going to watch some more videos. We're just going to kind of play around and get a little acquainted with what engineers are doing these days, who engineers are these days. We're not going to really start working on Chapter 1 until next Monday. We're going to stay on this schedule that we've got. So it's a fairly low-key day. What I would like for you to do is to maybe take some notes. Well, not maybe. I would definitely like you to take out a piece of paper, put your name on it and the date, and take some notes on the things that we watched today, things that interest you, things that you want to remember. But most importantly, I want you to write on that piece of paper at some point during our videos. I want you to write 2 or 3 questions that come to your mind about engineering or about engineering education or whatever. Questions that come to you that you can ask me that I can hopefully try to address for you as the class goes on. So that will be the format of today's class. We'll watch some videos and you will take notes and ask questions on your paper, and then you will turn that in. As soon as you're done watching this course, if you're watching the podcast of this course on YouTube, or if you're watching it DL, distance learning, either way, when you're done with that piece of paper, send it in kind of like a same-day assignment, and we'll do the same thing tomorrow. So not really a lot of set-in-stone stuff today. We actually may end up tomorrow spending a little bit of time. Actually, I think we'll spend a little bit of time both days, today and tomorrow, looking at some engineering websites. And I'm actually going to go to one today called engineering.org. And the actual engineering website is called engineeringforchange.org. And this is an interesting website. It's not all that old. It's only been around a little while. It's put together in partnership with a few different partnerships here. We have the International Electrical Engineering, Institute of Electrical and Electronics Engineers. There we go. ASME is the Association, the American, I can't remember what it stands for. But anyway, this was Engineers Without Borders, USA, which is kind of like Doctors Without Borders. They go all over the world helping people with engineering problems. But anyway, there are groups that really care about how engineering is changing the world out there. And so you can follow them on Facebook or Twitter or Instagram or whatever you want to do. And you can get in here and you can learn a lot of stuff about engineering and see what's going on out there. Engineering for water, for energy, for health. Lots of different things that they do here that they're showing what's going on all over the world. And it is really an organization that is pointed at helping the world get better. So a lot of stuff going on in the third world countries, a lot of stuff going on in education and so on and so forth. So here, that was actually really interesting. Let's go look at that. Right here, it looks like they're making heart monitor ECG pads. So they're making a heart monitor out of, how come I can't stay on that one? There we go. Out of bottle caps. So, a Bud Light cap and a little bit of copper wire. So here they've got a hand-propelled wheelchair that they made, it looks like. So, and these are people that are working in engineering companies. They're independent engineers and also engineering students. So lots of good stuff going on here. Engineering for change. Another good place to go are some of these engineering organizations. So if we go to IEEE, for example, .org, it's the world's largest professional association, right? And they have lots of different things that you can look at here. They have meetings all the time and conferences. But I'm going to go here to memberships, and we're going to look at member benefits here. So lots of different types of memberships usually. Let's see if they have an IE membership. New benefits, dues, let's look at dues and see. Here we go. So to be a member in the United States as a student, it's only $32, which is not too bad. And they will send you publications all the time. They've got their own magazine called, I think it's called Spectrum or something like this, which gives you the latest and greatest what's going on around the world in engineering. And they'll give you online publications in your email and connect you with Facebook and stuff like this. This is a great place to go if you want to if you want to have as many resources as possible as you go through school. Eventually, as an engineer, you will, even as a student, you'll be going to conferences and things like that. So it's good to know what's going on. You won't necessarily have to pay for anything like that, but usually those are paid for in the department. Let's look at the student resources here. Joining IE as a student, young professionals, extreme programming competition. Looks like they have a lot of things going on here, and they have special magazine for students, IE Potentials they call it. So the people that are actually submitting articles to this magazine are students as well as the people receiving it. Let's see if they allow free access to past issues. Doesn't look like it's free. It looks like you can get some information about it. You can get the abstract from it. If you're actually looking for the actual article, they'll probably make you sign up for a membership. But anyway, so that's IE. That's a big, really, really big one. There's also there are several others. Just about every field of engineering has their own society. So if you do mechanical engineering society, for example, they have that's the ASME. That's the American Society of Mechanical Engineers. That's what that one stood for. So if we go to ASME.org. Let's see, the reason I want to go to a few of these is because some of these student membership is free. And I'm trying to find one of those. I can't remember which ones are free and which ones are not. But let's take a look at this one. Go here. Come on in. What's up?
For 216B.
Yes, you want to join engineering? This is an engineering class. What are you looking for?
Mrs. Hopper.
I'm sorry? 216B. There is actually not a 216B. What teacher are you looking for?
Miss Hopper.
Oh. Yeah, I don't know. There we go.
Thank you.
Sorry about that.
That's all right.
Okay, so here we go. This is what we want to look at. Student member. So student member, this one is $25, so that's less. You can see that you're paying a lot less than most people, but still not free. You can get a membership for a lifetime. Request a quote. They probably ask how old you are and then calculate per year. Let's see what other ones there are out here. Let's search this way. Free engineering student membership. So National Society of Professional Engineers has join types of membership. There we go.
I think it was right there on the front page.
Was it?
Good.
Yeah, free NSPA National Student Membership if you're a student enrolled in a full-time in an ABET accredited engineering program. So we're actually technically not an ABET accredited program because we're not a 4-year school. They may let you get by because we're connected to UNL in some small way, but maybe not, I don't know. But that one is a free one, so when you get up to UNL or the Department of School of Mines or wherever you're going to go that has an engineering program, then you can definitely get your free engineering membership. And those are kind of nice because you get the publications for free, and you get discounts on going to meetings and stuff like this. So we can free student membership to Engineers Australia. There we go. Here's one for the American and Canadian students. Looks like they have a free membership possibly here. It's kind of slow. So undergraduate students attending U.S. and Canadian schools, Chevron is sponsoring this. That's nice. You can get your your membership is free. Apply online. So here's a free place. You can join online here, and that's great. Member benefits. You're going to get eligibility for scholarships. That's huge. Membership in 2 divisions or forums. So you're going to choose the fields that you're interested in. They're going to send you probably a newsletter about those every once in a while, and job opportunities and stuff like this. Great opportunities for these kinds of things. So, there's one that you can sign up for free. American Society for Engineering Educators is one that I'm a member of, and let's see what their student matriculated post-secondary students interested in engineering. They say $30 per year, but it's online. If you only get the online thing, it's only $10 a year. So you get all your stuff online, all your publications online, only $10 a year. That's not bad at all. So it's pretty good. That's Society for Industrial and Applied Mathematics. It's kind of similar to that. Society for Petroleum Engineers. $10 for your first year. Let's see. So in the Society for Petroleum Engineers, and that's a a really big engineering field right now, obviously. All the drilling going on in America and all over the world, really. And it's the highest paid engineering shop in the world today, right now. But $10 for your first year after graduation, and you get 1 year of professional membership. No, sorry, let's read it actually online, see what it actually says. So it looks like it's free. Student membership is free here. Must be enrolled at a university and carry at least 30% of normal full-time academic load. Have a concentration in petroleum or related field. So you'd have to be taking chemistry and engineering and stuff like that. Here it says you have to be pursuing a bachelor's degree, so that would be again when you're at the 4-year school. But this is definitely a great opportunity as well. So you have to attend a university with an SPE established student chapter to make sure where you go has a Supply Petroleum Engineers student group, student club, that a lot of them do. So anyway, lots of places you can go here. You can see the list is long. Places you can go to look for some opportunities to get some exposure to engineering, and I would recommend them. I would recommend any of them. What we're going to spend the balance of our time doing is looking at some video, of course, like I said. So we'll jump over to YouTube. YouTube is not necessarily the best place to get videos all the time, but it is the central hub for videos on the internet, so we'll just go there. I'm going to search for my engineering thing, which is MPCC Engineer. That's my engineering YouTube channel. And it kind of brought it up, because there's me right there, MPCC Engineer. And if you go here to my channel, you can see that we've got a bunch of videos from last year, I guess. But let's take a look at the playlists. We're looking for Engineering Fall 2016, which is, and you're welcome to look at any of these Engineering 1000s or anything else that I've got here. It's totally fine with me, but I'm not seeing my newest one. Engineering Fall, oh, it's 250. That's this one. It's not 2016, it's 2015. And so here I have 2 videos. The sound turned out pretty good, I think. Let me turn up the volume in the room here so we can see that, or we can hear that. It sounds like it's echoing, but it's not YouTube that's echoing, it's actually this room that's echoing. So it's got pretty good sound on it, so you should be able to follow on what we did last week on this channel. There are 2 videos for that first day, and my videos will be encoded with a title. I'll start with Engineering 1000, and then I'll put the date in day, month, month, day, year form. So 08/24/15, and this one has an A and a B, and sometimes that happens. Sometimes my recording stops early. I have to make another recording or something, and that happened last time. So I have 2 videos for the first day of class. My video for today will go under Engineering 1000 08/26/15, and I will post it here as well. And other interesting video lists that I have here for Engineering 2015. Cool Science is a fun one for engineering, but I also have this engineering one, which is the one we're going to go to. And we're going to watch all of these. Essentially what we have here is 6 videos where we go through kind of the life of 5 or 6 different engineers. These are profiles of engineers done by the National Science Foundation. They're very well done. And you're going to meet a variety of different engineers at different points in their careers. And you will hopefully notice and find out that engineering is really diverse. There's just a lot of things going on with a lot of different kinds of people. And the sky is the limit. It's wide open out there. And I think last time we watched some videos about 2 guys, and they were talking about a little bit about their frustrations, I think, with engineering, and certainly that happens in every field. But these ones here, I think, showcase engineers that have really found their place in engineering and are really starting to enjoy it. And most of the engineers that I've met reach that place fairly quickly, actually, reach that point fairly quickly in their careers. And I've known a lot of engineers, literally, not kidding, I've known hundreds and hundreds of engineers. Most of them I've known quite well. I grew up with engineers all through my life. So anyway, we're going to start off with these 4 videos, or these 6 videos, and I may stop them from time to time. You're more than welcome to interrupt, and I can stop it if you have a question. But I will stop them from time to time and talk about things and elaborate a little bit. So let's go ahead and get started here.
City of Chicago. And from Ken's viewpoint, it's the structure.
We're starting here.
Engineer Ken Moschke loves living and working in the city of Chicago. And from Ken's viewpoint, it's the structures that help bring the city to life. Every day, he gets to move to the pulse of a city filled with vitality, or ride, or climb, even skate.
So I'm going to stop it right there immediately, just because we don't live very far from Chicago. It's, I mean, you could get there in a long day's drive, but you could easily get there in 2 short days of driving. And it's well worth it. It is an engineering marvel, especially when it comes to its architecture. There's beautiful buildings, but also really interesting engineering buildings and bridges and everything all over Chicago. So I would highly recommend that if you can make the trip, do it. Go to Chicago. It is really the closest truly big city. I mean, Denver is kind of big, but it is the closest truly big metropolis city to us. And you can tell because the technology, the architecture, the civil engineering, it's everywhere. You know, from everything from the buildings to the elevated train system to the streets and roadways. There's things going on all the time, and it's a really interesting place to go. Also, there's a museum called Museum of Science and Industry, which is a great museum to go see if you have an interest in science, engineering, industry, and technology. They have an entire German U-boat, the only one that's intact from World War II, inside the museum. And so that's a really cool attraction to go see just for itself. But they have lots and lots of other things, great place to take kids. You do have to watch, you know, different parts of the city can be not so fun, but I would definitely recommend, you know, the touristy parts and the Magnificent Mile kind of part of Chicago to go and check out the engineering marvels in that city.
Just in time.
Ken is a licensed civil engineer at Thornton Tomasetti, a world-renowned engineering firm.
Civil engineering is really the jack of all trades of the engineering profession. It includes transportation, structures, what I do. There's geotechnical, construction, water resources. Together, it's mostly about the infrastructure that we all use and we live in.
Civil engineering goes back to the earliest days of civilization. If anyone's responsible for building this country, it's civil engineers.
Civil engineering is really a people-serving profession, especially when nature throws us a curveball. When it comes to hurricanes, tornadoes, earthquakes, civil engineers are there to make sure that the buildings, the bridges, and the infrastructure stays operating and stays safe for people.
Ken and his team.
I'm going to stop it right here and just to point out something kind of interesting. Engineers are fairly laid-back people. You can see here that there's not a strict dress code. You might think they all have to wear polo shirts, but as we go through this, notice that engineers, you'll notice that engineers are wearing all kinds of different clothing, different kinds of hairstyles, different kind of lifestyles, obviously. They're pretty laid-back kind of people, and it's not uncommon for an engineer to show up to work in jeans and a t-shirt, or even shorts and a t-shirt. It does happen quite often, actually. Of course, there are certain times when they have to dress in specific clothes for safety reasons or other, regulations reasons. But For the most part, it's not a bad field to live in if you want to live kind of a laid-back lifestyle. And when I worked as an engineer, there was almost no dress code at all for where I worked. The only time I had to obey any kind of real dress code was when we had a specific kind of meeting that day, so we were supposed to wear, business casual to the meeting with people that were coming in to talk with us about things that they wanted us to design, or when I had to go work in the clean room, in which case, I was going to be putting on a suit over the top of my clothes, and with all kinds of crazy stuff going on. So, besides that, it's an atmosphere that is really nice to work in, if you like the laid-back life, which I think a lot of people do. So,
Specialized in structural engineering.
Very simply put, structural engineering is making things stand up. Already in my career, I've worked on a huge variety of projects. I've worked on baseball stadiums, football stadiums, practice fields. I've worked on high-rises here in Chicago and even internationally in Denmark and in the UAE, in Dubai. The architect usually gives us a pretty picture of the skin of the building. A structural engineer really looks beyond that into the guts and the bones that hold up that skin.
The team is on their way to one of Chicago's most beloved icons. Rising from the ashes 17 years after the Great Chicago Fire, the Rookery Building was completed in 1888.
Many times we get involved with historic construction and trying to preserve it. At the Rookery Building, we're going in, evaluating the existing structure, and trying to come up with new ways so that crews can keep it in top shape.
The walls fall on masonry bearing walls, and the interior is also done frame construction.
In the drawings, the civil engineers see a story of imagination and innovation.
Pretty cool.
Elevators, electric lighting, plate glass windows, fireproofing, features that define the modern skyscraper. Ken has a desk, but you'll rarely find him there.
Let's open up the drawings and see if we can find out what's going on. Looks like there's a step here, so I'm betting you see how they have the two beams adjacent to each other. That one of these is going to be high for this part. This bay could have a little more snow load on it.
Then it's off to a presentation. Remarkably, Ken's day has just begun. Ken grew up on a farm, so you'd think the big city would mean a big adjustment. But in just a few short years, he's developed a special connection to the city.
One of the reasons I went into structural engineering was because I wanted to be able to show people what I worked on. I've worked on that building over there. Here's another building I've worked on. Another one on this side of the river. We worked on the Chicago Board of Trade building too. When I was in high school, I didn't know necessarily that I wanted to be a civil engineer. I was good in math and science, but I think the best engineers are those that are very well-rounded and bring together a lot of different ideas.
Some of Ken's projects involve routine structural maintenance. Others push structural design to the limits.
Imagine putting a 50-story building on top of Union Station. That's what structural engineers do. This meant that we needed to look at all the existing foundations and the columns and imagine a way to support the weight of a new structure on top of what was already there.
What most folks don't see are the design challenges that Ken has to face.
If a wind gust were to go and hit the building, this behavior that it would most likely start to move in. If it moves too quickly or too much, people might get sick, and then there's no way you could sell space on the top floor.
A city would not be a city without buildings like these, or without rail lines, bridges and roads, water and sewage systems. Things people count on to keep their city working.
There's a lot of work that's involved with maintaining all of these parts of the infrastructure. And I guess engineers need to be a little more Clark Kent than Superman.
That's why civil engineers don't just work with companies like Ken's. You'll also find them in municipal, state, and federal government settings, research facilities, and universities. Ken holds Bachelor of Science and Master of Science degrees in civil engineering.
Very rarely do I work on anything by myself, but together that helps us to come up with the best solution to the problems.
In a sense, their job is to pave the way for the future by incorporating new materials, building techniques, and new ways to save energy.
This is a project that I worked on with some architects, trying to envision a way to use a currently undeveloped site in Chicago.
So here you can see that he is obviously using a three-dimensional drawing program, and that is something that we will get a chance to do later in this class. And it looks very similar to this, in fact. I'm not sure, I can't really tell which one he's actually using, because they all look very similar, but you can see that it's very much like any old Windows program. It used to not be that way. These three-dimensional drawing programs and design programs used to be very different looking than a program that you're used to looking at. It wasn't anything to do with pointing and clicking, for example. There was no mouse action going on. Then you did almost everything from your keyboard, which was annoying, really, and difficult to learn. But nowadays you can see that you've got all these shapes up here, and so you can just click on these shapes and bring them down here and stretch them and pull them and all this stuff. And you have all these tools over here where you can create curves and you can create lines and do all this measuring and fill in colors and textures like this. This one actually looks very similar to the one that I'm going to be teaching you. And so it's not a difficult thing to do anymore these days. It's actually quite simple to learn how to do these things. And so you have a great advantage being born in a time when technology is where it is at.
We think the idea that we're presenting with green technology offers a way of the future, how buildings in the future will need to be planned and designed in order to be more sustainable in our infrastructure and in our cities.
Green ideas like these are changing the way buildings are being built and renovated all over the world.
I think there are so many other difficult questions in today's day and age dealing with the environmental impact of the building, how to deal with the building's
I'm
energy
going
needs.
to skip to a new one just so we can see some other ones here.
My name is Nate Ball, and I'm a mechanical engineer. My job as an engineer is to use what I know about the world, what I know about how things work, to solve problems to help people.
As a mechanical engineer, Nate pushes technology to its limits by using his knowledge of motion and energy to develop all sorts of mechanical devices, including a new vaccine delivery system called the VacPack.
There are about 4.3 million deaths that are caused every year by vaccine-preventable diseases. And a major challenge in getting vaccines to the appropriate places in third world countries is being able to keep them at the right temperature. Vaccines have to stay, in general, at about 4 degrees Celsius in order to stay usable. And to get vaccines at that temperature into really rural areas with spotty electrical power is a big challenge. This device here is a portable vaccine refrigeration backpack. It's like a refrigerator you wear on your back that allows you to take up to 1,200 vaccine doses into a rural area that doesn't have normal power. So in a situation where you've got major infrastructure devastation, like in a huge earthquake in a third world country, a device like this has a great potential to make a big difference because it can take massive doses of antibiotics and needed medicines into rural areas that have no power in order to be able to deliver the needed medical help.
Nate spends much of his time refining his designs and building models and prototypes to get products ready for manufacturing.
What we're looking at here is a 3D model of an early version of the backpack that's actually created inside the computer. So in engineering, if you're building a complicated system, it's very useful to build a model like this in order to visualize how all the parts will actually attach together.
Nate shares his passion for engineering by mentoring others. He even hosts a TV show for PBS called Design School.
So on the show, I get to mentor a couple of the teams of young engineers and introduce challenges to them as week to week they split into teams and hear from a client, kind of like real engineers do. And the client says, hey, Design Squad, I need you to build this for me. I need you to solve this problem.
I want you to build me the fastest dragster possible.
And the kids on the show actually go out and do it.
All right, so we got our forks up in front.
We're gonna have a 6-foot coil of rebar, like a tornado.
When he's not inspiring future engineers, Nate can often be found helping athletes reach new heights.
I actually coach some of the MIT pole vaulters here. And I'm also a pole vaulter myself, and I have been since about 6th grade. It's kind of cool because coming to pole vaulting from an engineering perspective as a coach, I get to describe physically what's going on in a different way that other pole vault coaches might do. This is where the box is. You want the bar to be back away from it so that when you peak, you're not going to fall back down into that steel encased in concrete. The neat thing about engineering is that it allows you to solve all kinds of problems, ranging from building cool things like dragsters and bridges and skyscrapers to solving interesting, complicated problems like how do you get a drug directly into your skin without the use of a needle.
When a natural disaster or a fast-moving epidemic.
So I'm going to stop this one right here for a second. So our first engineer was a civil engineer and did what we expect civil engineers to do. This guy is a mechanical engineer. He's doing a little bit different things because he's doing stuff that's going to go off in the third world, and he's doing some stuff like the self-ascender thing that pulls people up a cliff or up a building. But still, I think very much what we would expect mechanical engineers to do. Here's something we don't expect necessarily to see in an engineering video. Let's watch this.
Shoot right down the line and inoculate a huge amount of people in a very short amount of time.
Nate's a busy guy, even during his downtime.
I guess the physicality of getting out and doing stuff with your body is a nice break from your brain, and being in some kind of shape physically kind of helps us work harder mentally during the on-out. We really enjoy getting out there and working hard and flipping upside down and sort of, I guess, applying some kind of physics understanding to what's actually happening in the air as we run and flip through the air off of obstacles and what have you. Engineering by no means is all fun and games either. It's never going to be a...
So the reason I show that is because that's actually not uncommon among engineers for them to just be kind of wacko, to do weird things, have weird hobbies, because those kinds of things are fascinating to engineers, and engineers are fascinated by the world around them. And so it's not uncommon at all. Don't think that your little quirky habit or your little quirky hobby over here is going to be frowned upon in engineering. It never is. There's every variety of person you could possibly imagine. You will find one of them in engineering, or a lot of them in engineering. Sports that are really popular among engineers that people don't necessarily expect. Cycling is hugely popular among engineers, and I think the engineering aspect of cycling is a huge draw for them. But also, mountain climbing is a huge thing for engineers. There are a lot of engineers that love rock climbing, sport climbing, alpine climbing, mountain climbing. And again, there's a lot of technology and equipment involved with that, but I think they're just fascinated by the nature around them. So I'm going to go to another one really quick. We've still only gotten to the second one, and we're running out of time here. So let's see more.
Okay, so maybe you need to put a delay between turning on the burst. Have you guys looked at the data?
Tell you how many.
It's really fun to be able to touch something and think of something and solve a problem that no one has ever been able to solve before. Do you have any way of plotting what the optimal frequency is for each one of the positions?
I could track that.
My name is Yale McGuire, and I am Chief Technology Officer at Thing Magic.
Yale has been building things since he was a kid.
I remember when I was about 12 years old that I really took an incredible interest in designing and building radio-controlled vehicles.
And now, designing and building things is his job. Like this little piece of technology that's starting to make a big difference.
This is a tag. This is an RFID tag. RFID stands for radio frequency identification. These are invisible waves that communicate information from one point to another. Well, if you snip this in half and then add more capacity.
Yale and his team make the readers that take the information stored on the tags and send it to a computer.
we can use this to identify objects uniquely and have a computer understand what those objects are by just sticking them on there.
So if you are wondering what these are what we use to open the doors of this building these days, RFID tags. And they're essentially just an electrical circuit that that reacts in a specific way to a field, an electromagnetic field, which is also called a radio frequency field. And it can be recognized by the way it reacts. And it's fascinating stuff. Nowadays, just about everything gets an RFID tag. Your hotel keys have them. Our keys here on campus have them. Each one has a specific, unique signature to it. But they put them on shipping items. They put them on packages at FedEx. They put them all over the place because they're not very expensive, and you don't really have to scan them. You really just have to have them nearby your scanner, and the scanner just does it. It's not like you have to walk up to it and point something at it. If you're nearby and your scanner device is powerful enough, it can pick up all the RFID tags in a room, and you don't have to go and look at them individually at all. And it's beautiful. It's a wonderful thing to have. So
I got something to add on to that.
I'm sorry?
Walmart is looking at getting rid of their cashiers because of RFID tags.
Yep. Yeah, and I mean, if they use RFID instead of UPC, then they don't have to worry about shoplifting either, because all you do, and you have an RFID. This is really controversial, actually. Walmart really wants to do this, but they really want people to have a debit card or a credit card that's RFID, and all their merchandise RFID. So when you walk out the door, it just scans you and charges you for everything, and that's all you do. Everything that you take out, you get charged for. I mean, it would be a great idea for people who are honest. For people who are dishonest, they don't like the idea at all, you know? I think it would be kind of bad for people who are trying to keep track of their purchases, because people that are on a budget, might spend a little too much and not even know it. But yeah, it's actually something that they've talked about quite a bit, and it is very controversial because it's just a little too. People are still a little worried about it, I guess. And there are things to worry about. You could switch RFID tags with the two different objects if they weren't hidden well enough. There's lots of things, lots of problems that could go on in that way. But I think that the manufacture of these things are getting better and better. These things are getting so small that you probably would never be able to find them anyway. And in fact, they can actually make them on a micro scale so that they can actually tag, like people that break out of prison can be tagged with RFID as they break out. They can be tagged with micro RFIDs, and then they can be tracked for a certain distance. So that's kind of interesting. You can use them for all kinds of things. So it's very interesting the possibilities here. The possibilities for we talk about privacy a lot. For example, if you have an object with you that's RFID tagged, then your privacy is going to allow to. Everybody, anybody who knows your RFID can tell where you've been, can track you if they have a powerful enough device to do it. That's a little off into the future, but it's good.
The main problem that Ford was trying to solve was people would have to travel for a long distance to get to a particular job site, and if they got to that site and they realized that they had forgotten, their scroll saw or something like that, they'd actually have to go to a local store and buy one, and those things are really expensive.
These tags will let a pickup truck know which tools are in the back and which ones aren't. But that's just the beginning.
Basically, having access to information and more information about objects allows us to be more efficient about how we transport them, manipulate them, handle them.
Produce traveling from the field to the store, for example, can be affected by changes in temperature. RFID tags might just be the answer.
With special types of tags like this that can actually record temperature, maybe it will mean that we can send this product out such that when it actually reaches you, it's fresher and newer and tastier.
While electrical engineers are problem solvers, using their high-tech understanding of circuitry and electronics, it can take a long time for an idea to come to life.
Typically, to make a product that can survive all of the difficulties in the real world, it takes about a year.
Which can mean long hours of meetings.
So about a year to get a product out there in the real world on average. But some of them take much longer, some of them shorter.
Designing, building, and lots of testing.
So I do a lot of walking. I'm certainly not complaining because I have so much fun having to pick and choose between these different things.
So notice in all of these, the engineers are spending a lot of time collaborating, a lot of time going around to people, meeting with people. It's a skill you have to develop and you have to learn about and you have to get good at. Certainly a skill that I'm not perfect at. I struggle sometimes dealing with people. But as engineers, you have to learn that because you're going to be working with people from the public sector, you'll be working with people from the government sector, people from the private sector, people from all over, and also fellow engineers and accountants in your company and other things like that. You have to learn to work with a wide variety of people and learn how the human interactions go, but not only face to face, but also through email, by phone, social media. All these things are things that you have to learn to work with professionally. It's different than your normal life because as an engineer, you're a representative for engineering, for your company, for whatever. So that's another big aspect of engineering that they're showing us here. So I showed you parts of 3 of these videos. We're out of time at this point. Make sure that you do get your notes to me as soon as you can, as soon as you watch this, and take your notes. Make sure you've got 2 or 3 questions on there that you want to ask me, and you can turn those in. You can turn those in anytime you want, but get them to me as soon as you can. So have a good day, and I will get this posted to YouTube.